So the real advantage of logarithms is to be able to bring exponents down, and we're going to be able to use logs when solving exponentials when the bases are not the same. So our objective for this lesson is to be able to solve exponential equations when the bases are not the same. So first of all, the key idea for this, when the bases aren't the same, is to take the log of both sides. That allows, remember what you do to one side of an equation, you got to do to the other, but when you do that, it allows you to get the variable out of the exponent, and then you can just deal with the logs as values. This is a critical idea. It's kind of the pinnacle technique for solving these, because most of the time we're going to have different bases when we're solving exponentials. So let me show you this with two different methods. Kind of the old method of doing it and the new method, and then we'll do problems that you have to do it with the new method. So first of all, if we have 8 to the x equals 17, to solve this one, the first thing I'm going to do on this one is use just our circle tool and set it up into a log. So we're going to say log base 8 of 17 is equal to x. Notice that's the easiest way to do this one when it just has it on one side. And now I can use my change of base theorem. I can make this log of 17 over log of 8 is equal to x. Then I could bring out my calculator. And so on my calculator, I'm going to do log of 17. And then divide that by log of 8. And I get about 1.36 approximately. So x is approximately 1.36. So that is the quickest way, and it's a method to do it, especially when you have just one variable in the exponent. But now let's use our new technique. We're going to take the log of both sides. So for this, we're going to have log of 8 to the x equals log of 17. Now we have a property of logarithms that when you have an exponent inside of a log, you can bring it in front. So I can bring that x in front of the log of 8. And then to get x by itself, we're going to go ahead and divide by log of 8 on both sides. Now notice, if you see, we've already seen that before. That's what happened in this method. It happened a little faster than this, but this method gets to that same point where you're dividing logs, and we'll get our answer from this, which we get about 1.36 when we do it. So the technique that we're going to emphasize with this next one is going to be to take the log of both sides. When you have a variable in both exponents, it is going to take a little bit more time. You have to be patient, persistent, and follow the steps that that we outline here. The first thing, the biggest idea here, is that I'm going to emphasize that we need to gather the x terms on one side. Okay, so this idea is going to be an important one. You're going to gather the x terms on one side of the equation. You'll see when that step comes, but you've got to remember that's the thing we're targeting for doing here. So because we've got exponents that include variables, we're going to take the log of both sides. So log of 2 to the x plus 4 equals log of 3 to the x. Now we're going to use our rule that says if you've got exponents inside a log, you can bring it in front. So x plus 4 times log of 2 is going to equal x times log of 3. Now this term has an x in it, so I'm set with that one. But here I'm going to distribute through the log of 2 to both of these terms. So I'm going to have x times log of 2 plus 4 times log of 2 is equal to x times log of 3. Now what I'm going to do is take this and I'm going to gather the x terms, the ones that have x's in it, together. So I'm going to move this one over to the other side by subtracting it from both sides. So 4 log of 2 is equal to x log of 3 times log of 3 minus, and I'm going to have here x times log of 2 here. All right, so now that we've gathered the x's together, I can factor out an x. That was why we gathered them on the same side. So you have 4 log of 2 is equal to x times log of 3 minus log of 2. And now to get x by itself, I'm going to divide both sides by this long expression of log of 3 minus log of 2. And let's go ahead and do that on our calculator, see what that equals. So log of 3, 4 times log of 2. So we can get 4 times log, let's do common log of 2. Okay, first of all, now I'm going to divide that by, and I'll put it in parentheses because I need to keep those together. The whole denominator has to stay together. So I'm going to do log of 3 in the parentheses minus log of 2. And end that parentheses and end the denominator parentheses. And so my answer ends up being 6.84 approximately. X equals about 6.84. And if you want to check, which you don't have to in this case, because we're not starting with on this one, we're not starting with a logarithm, you could put 6.84 or a longer version of that decimal in here, and you'll see that they're about the same. Because we rounded, they might not be exactly the same. You'd have to use a longer version of the decimal to get that. All right, so that's the technique. You get it so that you take the log of both sides, bring the exponents down, you go ahead and distribute through, and then bring the x terms together, factor out the x, and divide. You get your answer. Now let's finish off by doing the same idea here. Now we're going to do it with an inequality. So solving an equation, solving an equality, very similar. We're going to take the log of both sides, but there's one caution. You're going to do the same process, but when I divide by something on both sides, I got to make sure I'm not dividing by a negative. In many cases, you're going to see that the thing that you're dividing by here might be a negative, which would reverse your inequality. So the caution here is when dividing, check to see if you are dividing by a negative. So we just will have to check out, like for instance on this one, if I had checked it, if it had been an inequality, I'd have to check, is log of 3 minus log of 2 a negative? So just to show you how that looks, if this had been an inequality, okay, we just do log of 3 minus log of 2, and if we check that out, that's not a negative. It's a positive decimal, but it's positive. So if this had been an inequality, we wouldn't have had to flip the inequality. All right, let's try this next one. Let's follow the same steps. We're going to take the log of both sides. So log of 4 to the y is less than log of 5 to the 2y plus 1. We're going to bring the exponents down in front. So y times log of 4 is less than 2y plus 1 times log of 5. Now I'm going to distribute through on this one the log of 5, so y times log of 4 equals 2y times log of 5 plus 1 times log of 5 is just log of 5. Now I'm going to gather the y terms together here. So I'm going to bring this y term over to the other side. So bring this over and make it y times log of 4 minus 2y times log of 5 is less than log of 5. And now I can factor out a y. Y times log of 4 minus, actually on this one, I've got a 2 in front there first. So I first of all have to deal with that 2 well, I can have it here. So take out the y, I'm gonna have log of 4 minus 2 log of 5 is less than log of 5. I could move that 2 up to be an exponent if I wanted to. It's not necessary in this case. Now, divide by this on both sides, but I've got to see, I'm going to have a y, I'm going to have a log of 5 divided by log of 4 minus 2 log of 5. We've got to see, did I divide by a negative? Let's check it out. Let's go to our calculator here. Okay, and let's do log of 4. So log of 4, and we're going to subtract 2 log of 5, 2 times log of 5, 2 times log of 5 here. Now let's see, did I get a negative? You don't have to write it down, but we have to acknowledge that that's a negative. So I am going to write it here just so that we see why we're going to divide by this. This is a negative. So when I do that, I've got to flip my inequality. So just to recognize that by calculating this, I get a negative, that's going to flip the inequality. So this is going to be my answer here. If I do that on my calculator, if I were to do this division here, I'm going to get y is greater than about negative 0.878. Approximately, if I round it to the third decimal place. So just to see what the new technique is when you can't get the same base on both sides, you have to take the log of both sides in order to solve the problem by gathering the x terms together or the y terms, whatever your variable is, because once you bring the variable out of the exponent, you're going to have to do a distributive property, bring them together, solve, and when you do an equation, you just solve and get your decimal. If you're doing an inequality, just remember that if you divide by a negative, check out that denominator, is it negative? If you divide by a negative, you gotta flip over your inequality.